Hello everyone. I would like to welcome you all to today's Tech Insight on harnessing STAAD.Pro and IS 1893 for resilient structures. To the session, I'll give you a brief introduction of myself and our organization. I am Khushbu Verma. I am an structural engineer. I am here at Capricorn Technologies working as a solution specialist for structures. If I'll talk about our organization, Capricorn Technologies, Capricorn is India's leading design and construction management technology solution provider for architecture, engineering, and construction. We are one of the largest platinum partner of Bentley and an authorized training center. We have more than 300 dedicated team members, and Capricorn serves over 20,000 clients in the AEC and related industries. Capricorn has contributed significantly to the country's adoption of computer-aided design for more than 3 decades. And now we are the part of global. We are global part. We are delighted to inform you that we have a global footprint. To serve you with the best of our abilities, Capricorn Technologies is now a part of Arcane's group. If I'll talk about the introduction part, the introduction is about the earthquake-resistant structures and the software tools. The intersection of advanced software tools and established standards is essential for ensuring seismic safety in structural engineering. STAAD.Pro, a leading structural analysis and design softwares, allows engineers to precisely model, analyze, and design buildings to withstand the impact of seismic load and ground shaking. Meanwhile, the Indian standard IS 1893 sets the framework for designing earthquake-resistant structures, providing guidelines on seismic design principles and load calculations. So if I'll move to the codal provision, here you can see some codal provisions I have specified here, which we are going to use in our structures while assigning the earthquake load. If I'll talk about this VB parameter, it is nothing but design-based shear, which is the most crucial parameter in seismic design and represent the maximum expected lateral force that the building's structural system must resist to maintain its integrity and safety. Or you can say it is the total horizontal seismic force that a structure is expected to experience at its base during an earthquake. How you will calculate it? It is simply a multiplication of seismic weight of buildings multiplied by a factor or coefficient, which is called design horizontal coefficient. Here you can see design horizontal coefficient, seismic coefficient. To calculate the design horizontal seismic coefficient, we have a formula. In IS 1893, you can see Z/2. Z is nothing but the seismic zone factor, which is given in table 3 of IS 1893. SAYG, it will depends on the soil factor, whether the soil where you are creating your structure is medium or high, it depends on the soil type. If I'll talk about this R upon I is nothing but the importance factor. It depends on the type of the building. If you are going to create a commercial building, then the importance factor will be different. If you are going to create an important building like hospitals, then the importance factor would be more. So it depends on the type of the buildings which you are going to create. And R is response reduction factor, which we will see while I'll move to the software part. And how you will calculate this seismic weight of buildings, I'll tell you. In the codal provision 7.4.1, it is given in IS 1893. Seismic weight of each floor is its full dead load plus appropriate amount of imposed load. That means whatever the dead load on a structure, we will consider the 100% dead load while calculating the seismic weight. But we will not consider the 100% live load. We will consider the part of the live load for calculation of seismic weight for our structures. And how we will calculate the live load, how much we will consider the live load for seismic weight calculation, we will see. Here you can see the codal provision 7.3.2. If your live load is less than or equals to 3 kilonewton per meter square, here you can see, then we will consider 25% of live load while calculating our seismic weight. If your live load is greater than 3%, 3 kilonewton per meter square, then we will consider 50% of live load while calculating our seismic weight. Also, you can see here imposed load on roof need not to be considered. We will not consider any imposed load on the roof of our structures. So to understand it better, I'll take you to the live demonstration. Just give me a moment to switch my screen to the software part. You can see the deflection of this structure I'm showing here in the Z direction. If I show you the deflection of the structure in X direction due to the earthquake load, you can see how it will look like. It will look like this. How I have created this structure, how I have assigned the seismic load on this structure, I'll show you in the coming part of the webinar. So you can see this is the structure. If I'll go to the loading part. So one thing I would like to tell you, when it comes to the earthquake loads, we do our entire process in 2 steps. The first part involves definition of seismic loads and the seismic parameters. Second part is creating load case details with respect to these parameters. I'll show you how you can do this. And this structure, I have already assigned the seismic load. You can see here. And all the load cases here you can see. Now I'll show you in the another structure how you can assign or define the definitions so that you will better understand how you can apply the earthquake load. This is the structures. I have created the geometry, assigned the properties, also assigned the supports. I'll start from the loading part. This is the loading part. To assign the earthquake load, first you will create a definition. Here you can see the definition option. Just click here on the plus button. Move on to where it says seismic definition and then click add. Here we got the options of defining our seismic parameters. Like you can see here, the different parameters we have to fill in. First, we will select the code. Select the code. I am here. I'm going to use the IS 1893 code. Then standard. Either you can manually enter these data if you have, or you just click here on generate button. Once you click on this generate button, you can see this window will open. Here are different parameters, seismic parameter, which you have to enter. Accordingly, your output will come. Like you can select your city where you are going to construct or create your structure. Suppose if your city is not listed here, but you have idea where in which zone your structure is going to create, so you can select the zone also. Suppose I'm taking the zone. I'm taking the earthquake zone as 4. Earthquake zone has been divided in 4 parts. Zone 1, zone 2, start from 2, zone 2, 3, 4, and 5. I am taking the zone 5. So here you can see the value of zone factor is 0.36 automatically taken by the software. Response reduction factor. Suppose as I am taking the zone 4, 5, and the zone factor is 0.36, which is very high. So I'll take RC building with special moment resisting frame. So you can see the response reduction factor 5. If you select ordinary moment resisting frame, so the response reduction factor would be less. As of now, I am selecting RC frame with special moment resisting frame. It basically depends on the concrete type. Now I'll talk about this importance factor. As I have already told you, importance factor depends on the type of the buildings. Accordingly, the importance factor would be taken by the software. You will select the building type. Suppose you are designing your important buildings like hospitals, then your importance factor would be 1.5. Similarly, for residential and commercial buildings, it is 1.2. As of now, I am selecting all other buildings. So the importance factor would be 1. Now you will select the soil type. I am taking the medium soil and structure type or RCMRA buildings. Damping ratio by default 5%. That is what IS 1893 recommends. And then you will click here on generate. Just click here on generate and click on add. Close. So here on the right hand side, you can see your definition has been created. So this is how you can create a seismic definition, and then you will assign the loads. The loading part I'll cover in my next insight. For more videos and updates, do subscribe our channel, Capricorn Technologies Private Limited, and like and comment if you like the insight. Thank you. See you next week.